Good evening. For years, we've been wondering the age-old question about should we renovate or build new, and what's the environmental impact of each of these? We think about saving an existing building and the embodied carbon. We also think about the performance of the new building. Well, these days we have the tools to be able to answer these kind of questions, and that's what I'm going to spend a little time talking about with you right now. My name is Chris Schaffner. I'm the CEO and founder of The Green Engineer. We're a sustainable design consulting firm located in Concord, Massachusetts. And this comes from a question that was posed by a building committee member on a recent project of ours. You can see the full text here. I've asked for the project to provide the community an accounting of the full climate impact. This is not about operational carbon impacts already projected by the project team. This is accounting for the full embodied carbon cost. This is relevant in this case as you're planning to demolish a useful building. The evaluation must include the embodied carbon loss of the original structure, plus the estimated embodied carbon to be expended to create a new facility in this location. The use of LCA has grown a lot over the last few years. We've got a lot of great tools to do that now, and so we can start to do this kind of analysis. Well, let's give a little bit of a context. When we think about the building's impact on the environment, one of the big parts, of course, are the CO2 emissions, climate change. And we think about the operational carbon coming from the energy consumption, but the building materials, of course, are also a big part of it. Some slides we've gathered from the Architecture 2030 folks illustrating this. And a thing to think about is that the embodied carbon happens right now, whereas the operational carbon happens over time. So eventually that operational carbon number becomes very big, but that embodied carbon is happening today. And if we're really worried about the next 10 or 15 years and getting through the eye of the needle of climate change, we really need to think about the embodied carbon as a key part of that. And this also becomes important when we think about our buildings being more efficient. As our buildings are getting lower consumption of energy and cleaner energy sources, it means that embodied carbon piece is becoming a bigger and bigger part of the whole picture. So when we look at the embodied carbon, again, from our friends at Architecture 2030, they tell us that a big chunk of that is actually from three materials: concrete, steel, and aluminum. And so that means that it's really the structure of the building is most of the embodied carbon. So that means even if we're renovating a building, if we can save the structure, the enclosure, some of those pieces, we can save a significant amount of carbon. And there are other benefits, of course, of reusing existing buildings. There's the historic nature of it, and just the amount of waste that's created and the cost as well. We participated in a recent project with our friends at Flansburgh Architects in Webster, Mass, and they did a calculation of the difference in materials, new construction versus renovation. You can see the impact is pretty huge here. The how many less materials we need when we renovate. So the question we've got now is we're going to build new or we're going to renovate, and so let's figure it out. So let's look at our real project that was the prompt for this original inquiry from the building committee member. It's a community center in Greater Boston, and there are two alternatives. One is a new build option of 32,000 square feet, and the other is an add reno option where we're going to use the 11,000 square foot existing building and add another 24,000 square foot to accommodate the additional program requirements. So let's do the analysis. So we're going to do the operational carbon based on the existing utility bills for the existing building. Plus, we're going to use an eQuest model to model the new construction alternative. And in this case, to keep it a little simpler, we're going to assume that the addition portions of the add reno have the same EUI as the new. And again, on the embodied carbon option, we have a full design of the new construction. So we're going to use one-click LCA to do that analysis. And we're going to assume that the addition will have the same embodied carbon per square foot for that portion of the building. Well, here we are with the results. Our new building, 32,000 square foot with an EUI of about 36.5. It's going to have an operational carbon annually of 76.6 metric tons CO2 equivalent and an embodied carbon of about 1,400 metric tons. Our add reno option, our existing building has a terrible EUI of about 108, which is 75% gas. The new addition, we assume, will have similar energy. And overall, now we end up with a building with an EUI of about 59. So our operational carbon for the new building is significantly higher, 124 metric tons, but we reduced the initial embodied carbon because we've saved that 11,000 square feet. And so if we put that all together, we get kind of a simple payback. and it tells us that in 7.4 years, the operational savings will outweigh that extra embodied carbon. So it's not to say that this is an answer one way or the other. There are other factors that go into the whole thing, including budgeting and the program of the building. But now we can answer this question, and we recognize that in this particular building, the benefits of new construction will overcome the extra embodied carbon in a little more than 7 years. Thank you for your time, and happy to follow up with any questions. Chris at greenengineer.com.